Assalamualaikum sir, my name is 3+Ashik and my ID is 2355802 When someone closes the yellow line, the RFID sensor generates a pulse, and this pulse is an analog signal, and this analog signal converted to a digital signal, and this digital signal goes to the FSM and the counter. The counter increment by one. The new counter is sent a digital signal, and this digital signal go to a converter through convert analog signal, and this analog signal go to control room. At the same time, if RFID sensor generate 4 pulse within a short time window, the alarm logic detect this and trigger the alarm. The FSM immediately close the gate and stop further entry. If counter reaches 10, the FSM will no longer send an open signal until the count decreases. Second question, here as we can see a block here 00 means no passenger detected. 0 on, read the RFID sensor to verify the T-gate. On 0 means the open the gate, and 1 on, close the gate. Here we design this is a finite state table. On this, the signal will go to the signal 00 or 00, all output 0. For present state 00, and next state 01. 01 means ideal means no passenger detected, and rest of the output 00. And next state 01. 01 means RFID sensor detect and verify the T-gate. For the verify the T-gate, clock activate, and rest of the output 00. Next state 10. 10 means open the gate. Gate will open. For the region, this output activate, rest of the output will 00. On this, for the on 0, next state 1 on. 1 on means close the gate. Close the gate, rest of the output 00. Here we will derive the equation for outputs. For ideal 1, present state 00. For 00, here we derive the sub expression PS1 bar, PS2 bar. For clock, present state 01. 01 means PS1 bar into PS. For open, input 10. 10 means PS dot PS bar, PS2 bar. And last but not the least, close the gate, and this output input 1 on. 1 on means PS1 and PS2. And final equation NS2 for NS2 rest bar into PS1 PS2 bar dot go plus PS1 into PS2 bar. NS2, here rest is the common point. NS2 rest is the common point. For that, here we get common, and we will get rest on bar and PS1 exclusive PS2. This is our Verilog HDL code to solve the system. The alarm triggers if more than 3 passengers close simultaneously. 4 sensors can be used in that case. The alarm function A3, A2, A1 and A0. I implement this function through a NAND gate, and these are implementing to get the function. Easier to achieve longer delay, we need higher resistor and low capacitor. This is the main theme to solve that question. For that, we will calculate R1 and R2 resistor to get our desired high resistor. Through this calculation, I choose 15 microfarad capacitor for higher values of resistor. This is our suitable 3+5 circuit for monostable. Why I use monostable circuit? In monostable mode, the 3+5 timer produces a single pulse when triggered the pulse with T. T is determined by the resistor R and capacitor connected to the timer Q. In question 5, they will say show the DAC output voltage represent the passenger count 5 and train. Assume DAC 4-bit, and for the count 5 passenger, definitely here 4 input, and this is our desired R2R ladder circuit. From R2R ladder circuit, simply we will find Vout for 4 output. Simply we will get 4 Vout for 4 is input. Sum up all this, then we will get our total Vout minus 3.125 volt. In question number 6, I will identify some limitation of developed metro system. The system is fixed to allow only 10 passengers or 20 tickets, so it cannot manage bigger crowd unless upgrade the full system. If 3+5 timer stop working, the entire system stop or shut down. The RFID sensor might mismatched or miss some passenger, loading to counter or counting error. The analog signal sent to the control room might get affected by the noise. That's all from me. Thank you, sir, for your valuable attention.